if I have to put, I want to solve problems with as little resources as available. That is something that is a thing that most of the middle class families in India face. So that's always on top of my head in general, whether in professional or personal life, anywhere across. If you go for a formal introduction, basically I've worked on the hardware side during my studies, intermediate and BTech, then a lot of pet projects during college. Then I started working on Nokia Symbian phones. Those were the phones at that time that we used to have. I used to write games and some apps at that time. Um, and then when I started my professional career, I was into mainframe computing at the time. Then our regular web, Angular, React, your regular backend microservices, cloud stuff. And then I went into DevOps. I'm more of a person who explores a lot of technologies in general. After DevOps, I went into Android mobile apps, native React Native side. And then I had interest in working on Android OS and custom recoveries. Verily on the custom OSs, majorly working on Lineage OS in general. Now I'm trying to explore data space. And while I was doing all of this, I had some personal projects that I was doing all along. Uh, cool. Uh, Hopefully that should be my intro. We'll quickly go into the backstory part. As we are going through these slides and stuff, please stop me at any point in time and ask questions. Organizers at any point, if I by any chance I miss the hands raised or questions, please stop me at any point.
Yeah, sure, Sultan.
Cool. The backstory of this to this point is, I think in the very beginning of the COVID phase, we were in hanging out in Telegram groups. One of the BTech students from Delhi, he had some issue on his mobile. He was not able to boot it up. So we talked for a bit, and then I helped him figure out how to fix his phone. After that, we had a couple of conversations, and I got to hear a lot of his fear, more in terms of COVID impacting his studies. And for him, it was really important to get a job right after BTech, so that he can support his family. He was from EC student, but as most of India, I knew that most of the people won't get a job in EC background. So I suggested him it'll be easier to get a job in the computer science, which he was really interested in towards anyway. Since he did not had any computer at that point in time, I helped him set up a development environment on his mobile, where he has a GUI desktop environment. Little did I know he spent like 18 hours a day practicing a lot and learning, as he's from ECE. Even though it's like really inspiring, at the end I also felt really bad that he had to spend so much time on such a small screen. It impacts his health in the long run. After 2 years, like we were talking here and there all the time while he was doing all of this practice and COVID gone by end of his third year, I think he landed a job already in his college. I felt really good about it. So this is the backstory of it. Majorly, even though he was able to practice programming and stuff on his mobile, I felt that it could be improved a bit so that people can really make use of them and still have a good health run alongside. So the problem is, in general, even when I was studying, I saw the same, that a lot many students in their computer degrees or any computer studies are not able to afford computers and hence not able to practice or learn. While I actually did this and then demoed it to few college students, I realized that few students have called out that even though they have colleges and computers, those computers barely work. Like for some computers, if monitors were not working, for some of them CPUs were not working and stuff like that. So some of the students, they were like even in college we don't have these things, we need to have something of this going on. That was something interesting to learn. The other is working on phone is not going to be easier, so it'll be very demanding for their eyesight and it will cause problem in a long run. Right. Some probable acceptable solution that I thought of at that time is like they should have at least a monitor to work for longer hours in general, a decent processing power to support minimal IDEs, your regular development environment of some sort, keyboard or some device that can help input easily. Like if you start to work on mobile, like even to enter very short Linux commands, it gets really tedious in general. So these are some things that I felt are a must-have in a solution that we might come up with. Cool. In my head, I was going through all different kinds of hardware and stuff that I have faced until now, and thought of what could be something that is really easy for these people to afford and still can fix a problem. One thing I felt is like mobile is in a very dominant stage, like especially during COVID, many families are forced into buying smartphones for helping their kids study in general. So also it is as part of my thought process, like we do more with the less. And these days the mobile phones are a lot more powerful than the regular computers. Like in comparison, the desktop that I used during my studies was like 2.4 gigahertz P4 single core with 512 MB of RAM. If we want to understand the time phase, it's like 2007 to 2011. These days, a very usual smartphone, you will find lot much better processing power, and you will have a lot more RAM in general, right? So I thought maybe we can use most of that. And this all composition of this PC is all about making use of the things that we already have for the most part, and spending for the things that we don't. Cool. I had like 3 setups in mind. First setup is like low powered Raspberry Pi, which looks something like this. This is called Raspberry Pi Zero, with a W at the end. W meaning Wi-Fi and Bluetooth added to it. It has fairly okay ports. It supports HDMI. It has two micro USB ports in general, to which we can connect keyboard, mouse per se. One of it will go to power. The other will have to connect to a USB hub, and from there we can connect keyboard, mice, and HDMI goes to your monitor in general, or a TV that has a HDMI supply. So even though this board doesn't have a lot of processing power, we'll make use of existing mobile power to make this work. So this is a fairly around 1.5K or so. Like even in many sites, you will find it at like 700, 800 per se, but depending on where you're searching and stuff, max you might find it at 1.5K in general. And then we are going to use existing mobile as computing power. We will see how we will use the mobile's computing power along with this. And then some HDMI enabled monitor or TV. If we already have a TV that supports HDMI, good to go. We can directly use that. Else we might have to buy that one. Keyboard, mouse, and some cables around this HDMI and micro USB cables and stuff. So all in all, like if we already have a HDMI enabled TV and a phone, like it need not be a separate phone that we need to have. It can be our parents' phone in general that we want to use it. And while using this setup, the phone need not be even like turned on in terms of the lock. Like it can be sitting in your in a shelf at home, and still you can make use of it in general. If you are using a monitor or a TV that has HDMI and we are using a phone, this setup costs around 2.5K. And that should be good to go. Or if we are looking for a HDMI monitor in general, like some of the cheap ones we can get for 5K, the new models in general. So it might cost around 7K or something around to have this around in general, like if you are buying along with the monitor. Setup one, the same that we discussed that now. We use Raspberry Pi as a terminal. For people who are not aware of terminal is a compute device which doesn't do a lot of processing. It just takes input, it just shows output. The rest of the processing, it gives out to a different device. So in our case, Raspberry Pi is the one that is going to take our input, show the display on the HDMI monitor as output, and the processing, it outsources it to our mobile device. Basically, we SSH from our Raspberry Pi to phone and then do our work in the mobile phone. And while doing this, phone screen can be completely off. We will see this in some time of how this works. Yeah. Any questions on this setup one as of now? Okay.
We don't have any questions, Sultan.
Sure, I'm proceeding further. Okay. We have set up two where we have a screen casting device. Cost you around 1.5K similar price. Again, we are going to use existing mobile as computing power and same HDMI enabled monitor and keyboard mouse. Similarly, the setup is going to cost us around 2.5K if we are using the monitor or a TV that has HDMI. The TV need not be smart. Whenever I'm calling out HDMI TV, it need not be smart. Just a HDMI cable that takes from your set-top box, that is good enough. Cool. So we'll see how this works, right? Screen casting device usually mirrors or replicates what we see on the device, which is going to be our mobile phone. In this setup, our phone screens will be projected onto monitor or TV using a Wi-Fi hotspot. Wi-Fi, if we have a router at home, fine. Our mobile hotspot should be good enough to get this going. Our keyboard will be connected to the mobile phone and it will work out of the box. We don't need to do anything for keyboard to work in general. Fun fact, Android kernels are much closer to our regular desktop kernels than we actually think. So they usually support most of the devices out of the box. If we connect a USB device that has some audio device, some let's say Ethernet cable or keyboard or mouse, they just support out of the box. You'll actually see a mouse cursor on your Android mobile screen if you connect one. Cool. We'll actually see a demo of this working. So this is with the cache device, right? So we'll have our mobile screen projected on this monitor. And we'll have the keyboard connected to our mobile. And here we're just showing some demo of what is going on across. Some regular keyboard, the full-blown keyboard connected to a mobile, and this is how your mobile screen might be like. Even though the font is smaller in the mobile, but on the bigger screen you will see it on a fairly large scale. Cool. In this setup, our mobile is going to be always on our mobile screen because we're just projecting our mobile screen, whatever we see on the mobile screen. Our mobile need not natively support casting out of the box per se, but any phone that is like above Nougat or Oreo, you by default supports casting in general in today's world. So any phone that comes out today usually is at least Android 10 and above. So I think that will have us covered. Cool. Setup 3, like if we don't have mobile phone, if we don't have monitor or TV or anything, then running Termux on mobile, Krishna Kumar T, yeah, there is Termux involved. We will see what all the stack is, and we'll see how it looks like in the demo part. Good. Is there one more question? Cool. So if we don't have a mobile phone or anything, I would usually prefer mobile phone per se rather than buying a Raspberry, a bit powered Raspberry Pi, because phone will help you on your regular daily things as well as the helps here. But if you go for Raspberry Pi, it would only be for only computing purposes. But anyway, if you go for this, you'll have a decent configuration, more like okayish or even lower than your phone processing power will be there. Again, you just are connecting it to a monitor, keyboard, mouse in general. Cost you around 10K or something if you buy all of these together. Cool. We'll get into software side overview. Mostly like if we are using Raspberry Pi to connect, then we are using a SSH server to be running on our phone. We'll use Termux. Termux is an Android app that gives us some okay Linux environment to run, like the bare Android that comes that doesn't have all the similar structure as a basic Linux compute system in general. So this app provides us that. And then we are going to use NeoVim as our IDE. You might have heard about VS Code and IntelliJ in these places. NeoVim is one good IDE which can work on terminal, as well as it can work as a standalone desktop application in general outside. But here we are going to use it as at terminal level. All of the setup that we are discussing, we can still go for desktop environment, but I would still suggest people to go with terminal based environment, because that is more than enough for regular students, as well as like even in the professional career of mine. From the past 2 years, I'm just using terminal based and doing everything in the terminal right from there. TMUX is a terminal multiplexer. We'll see what this is and how it works. Like, but if you are already familiar with something called Window Manager on your desktops, then this is more of that sort, but on terminals. And then we'll have some terminology like LSP server, formatters, linters. I think everybody know. But we are going to use some LSP servers in place. On a high level, LSP is nothing but language server protocol. This has come into existence after VS Code has come out, and Microsoft, I think, has put up this protocol so that you will not need to write or code your programming languages logic into all of the IDEs. Like if you are, let's say, having an IDE called IntelliJ. Now that IntelliJ IDE, if it has to support Java language, it has to understand what Java language is. Similarly, if you come to VS Code, then it has to write its own logic of understanding Java, being able to understand what is a function, how to go to definition of a function, all of that. But when LSP, so what they proposed is like, we'll take this out of a editor or as an IDE. It will be a standalone protocol where an editor can talk to this server and say, this is the file that I'm working on. Now this LSP is going to help us do those auto completions and all of it. So basically pulling all of that language specific logic out of the editor or IDE and pulling out into a separate thing. And when we have our IDE, it will be a barebone IDE, and we can add whatever languages that we want to support. We can just install those language servers, and our IDE will be now proficient enough to understand those languages and help us work on those. So on a high level, that is what LSP is. If you want to really learn more about LSPs, you can Google out. There's a lot much documentation on YouTube in forms of video, and there's a lot of documentation in general on your LSPs, GitHub and stuff like that. Your regular formatters, linters are, formatter is going to help you format your code. In general, linters are going to help you show you warnings in terms of code quality, or I would say the style of your code that you will be doing. Like if you want all of your team to have flower braces starting in the top line and ending in the bottom left, versus like you always have a flower braces opening in the in a new line, something like that. So those will be linters for you in general. Some of the LSP servers support all of these together in one. Some of those don't. So depending on that, you will go for these things in place. DAP is a debug adapter protocol. I know this is going a bit fast. In case people have questions, please pause at any point and ask me. DAP is debug adapter protocol. Again, I think it's similar effort by Microsoft, I guess, where we are not adding this functionality into an IDE of how to run Java code, how to debug Java code. Instead, there will be a debugger separate, and there will be a debugger client. And there will be this debug adapter protocol, which will help these two communicate and help us debug it. So if we write once a debugger, and if our IDE implements a debug adapter client, then it can talk to any debugger of any language, right? So that standardizes it all across all the IDEs. The moment these LSP and DApp came out, suddenly all your off-shelf IDEs have become a lot more powerful. Things like Vim, things like your Emacs, your VS Code, Sublime, all of these, instead of just being editors, now they are able to support all of these languages at an IDE level, thanks to these LSPs and DApp servers in place. So if we are writing a new, if you are creating a new language, if we are able to implement LSP server and DApp to it, then suddenly you have support for that language in most of the editors that are out. Yeah. And then we are going to use something called OMIZ shell. Mostly it will be like simplifying our shell experience on a high level. Yeah. Cool. Any questions on these? On the stack that we are using? We'll proceed further. As I said, I've been using the same stack for professional side for I think almost last 2 years. I've been using the same stack that we have here. Apart from these things that like I don't SH into anything, or I don't use Termux. I have my regular shell and regular environment to work on the office work per se. Yeah. So we'll start with the demos per se. I'll start up with this. So basically, I have this Termux and SSH server running on my phone. I'm trying to SSH. So the SSH setup is going to be akin to working on setup one that we had. Right? Setup one where we are trying to connect with the Raspberry Pi. So this need not be a very powerful system. All it has to just do is run a shell for us. And we are good to go. If we have a SSH client, we are good to go. So basically, we are trying to run a SSH client in my system right now. It is trying to connect to this thing on my phone, and I'm trying to log in. So we are able to log into phone, and here we are going to use multiple different softwares that we have seen, and then we will do some small demos across those and see stuff using it. Yeah. We'll see a quick regular demo to understand that it's all a regular your Linux environment per se. We have a pkg command here. You might have seen apt. Apt also works in this, so we can use either apt or pkg to install any package per se. Usually these are more like your app store if you are using Mac. Or if you are using some Windows system, then might be more like a Windows Store, but it's all terminal based package management. You can search for some software, you can install for some software, you can remove, you can update all of those things right from the terminal. Yeah. Your regular commands lstate cat all works same, right? So basically, this gives us a regular sane terminal environment on our Android phone. Yeah. Our Git aliases in general, like if we are going into this thing, usually your ZSH has some plugins that offers you some small aliases, more like your GST for Git status, GCO for Git checkout, stuff like that. But as we get familiar, we can start using those. But this is already a pretty forwardish platform. Like the more we learn, the more we can adapt and start using it at a higher level in general. Cool. Then we are going to look at Tmux. As I said, it might not be something that you might have heard earlier, but Tmux is more like a window management session for you on the terminals. Currently, I tried Tmux attach, meaning if there is any sessions present, we are trying to attach to it. If not, we are just trying to create one. So this is going to create us this a new window for us in the terminal. If you want to create more windows, we are able to create it here. So on here, if you want to work on something, it goes here, and we can switch to another window, and then we can do some more stuff here. More like a window management, being able to work parallelly on different things. This will allow, like if we just SSH into a system, then we are hardly working with one command and waiting for the output. But having tmux, that will help us, create multiple panes. This is a pane. We are in the same window, but we are able to create multiple panes. We can create as many as we want, depending on how we want. And as we organize our phone, we can organize stuff here. We can also save the setup, meaning if we save it like this, then next time we come, we can start it from here, right? Just curious, how was the battery life using it for longer durations? Battery life, I think, works really all right. Just like how your regular, imagine you are using another app in your phone. It would be in similar lines, and we are not going to use too much of a, like it depends on what we are going to use here. Like if you are a student just running some programs, it's not going to impact much in this setup. But if you are going for the cast setup, then your mobile screen is always on. And you're sharing that screen, that takes up a lot of okayish amount of battery, more like you're watching a video constantly. That kind of battery is what it drains if you are going for a cast setup. There we might have to think about charging, but like this kind of SSH based session, then it's not going to impact much. Yeah. Cool. So that's a very brief demo on the tmux part. It'll help us create windows or panes. We can attach, discharge, save session, and next time we want to reload, we can reload a session that we have already saved, right? For example, let's say if we disconnect from this session for whatever reason, then our work won't be going off. Many a time what will happen is if you SSH onto a system and then the connection goes off, your work goes off, right? And you're not able to do much of what you were doing earlier. You'll have to again restart or something. But tmux keeps tab of what you were working on, and next time you just log in, it just attaches your session to it, and then you continue from there. Any processes that you're running, like compilation of a program or anything, it will keep running in the background. You'll not lose any of the progress. So it helps on our regular work if we are a regular SSH person. Cool. NeoVim is the ID that we are going to use here. Basically, we will go through LSP, debugging, all of this as part of it. We'll quickly do a C demo. Cool. We can quickly see what are the recent files that we have opened here. Just like your regular IDE, you might want to look at the recent files that you worked on, and then you can open those files. We can have integration with Git as well. We'll see how it goes. So let's say I open this file. You see much description of it in terms of the kind of file it is, the language it is from, stuff like that. If you want, you can have a your file manager at the side if you really want it. And we will see like the same program if we have to write, how easier it would feel like your regular IDE that you might be writing, right? So we get the auto completion support. Just I type hash include, and then it shows me this, and then it even auto completes these part. Then if I'm writing some main part, then it shows me the main snippet. I can jump here, start writing the code, whatever that I want. And here, if you see, it is trying to auto-complete with the function that I've designed, described above. And it is showing what is the type of that and what is the return type that it gives, stuff like that. So we get the auto-completion snippet and all of those across, like your regular IDE. If you're looking at jumping to source of a function, then let's say we are hovering over this function call, we can say go to definition of it, and it will take us to the definition of it. Yeah. So works pretty much like your regular IDE in general. Now let's do some debugging part. I put up a breakpoint here. Hopefully it's visible for you, and we'll try to debug our program here. Um, so it is asking us for the out file that we have compiled from. So what I'll do is I'll try to compile this again, uh, so that we are not running with some old code per se. Basically, you can run any command from NeoVim, just like imagine you have a terminal right below it. You can run this and then it's going to compile your program per se. But if you really want a terminal out, you can any point in time you can, as you're using Emacs, you can come out of it. You can have your regular terminal here, or your NeoVim also supports terminal. If you want to create a new window with a small terminal, you can also do that. We'll not go into all the features or capability of NeoVim per se here, but we can just think that NeoVim will be able to do that and then handle all of those for us as well. I'll now start the debugging part. So if we start the debugging part, it's going to ask us especially because it's a compiled language, it is asking for the compiled file that we have in place. So once we give it, it's going to give us this new interface where we have all of these spaces. This is a expression or a watch list. If you have debugged a program, you might be aware of this part. If we put this, any expression that you want to evaluate, it's going to show us here. It need not be any variable that is present here. We can also make some expressions like this, and it's going to compute for us as well, right? We can see that red stacks. We can see all the local and global variables here in general. So from here, if we see, it's actually showing us what is the value of result here. This is a simple factorial program. So we are trying to multiply, like if you're here as part of this example, we are trying to figure out the factorial of 5. So we know the drill. It's 5 into 4 into 3 into 2 into 1. Here, since we are doing a recursion, it will go in the reverse, 1 into 2 into 3 into 4 into 5. So that is what we will see in the result here. So we can do a debug over. So it's going to go one step at a time, or we can do a continue over because it's a recursion. So we can see 2 into 1 result being 6. And then on the next run, 6 into 4 being 24. And then 24 into 5 being 120, right? Our regular debugging capabilities and stuff, anything that we output would end up coming out here. So anything in general that we might all, that's on a high level, the debugging demo part. If we are inputting some wrong things, it's going to highlight those errors as well, like our regular IDs. So pretty much basically your regular IDE stuff, we should be able to do it in this setup per se. Any questions on this?
No questions are posted, Sultan.
Sure. Cool. So that's on a high level on the LSP. We're just doing warnings, errors, or jump to definition of C language debugging that we have done. It looks very similar to if we go to a Python project, right? We similar Python thing. If we set up a breakpoint and then we go for
Sultan, sorry to interrupt.
yeah. Go on.
Like there is a question in Q&A from Krishna Kumar T. So he was like just curious, how was the battery life using it for longer durations?
Yeah, I answered it right there
Okay, okay.
when he asked it. Yeah.
Yeah, okay, all right.
Cool. All right. So even here it's the same. If someone wants to go through it, we can go through it, but we can very well put a breakpoint here and then run for the debug continues, and then we'll go through it in general. Cool. Next part here we see Mason. Mason is the thing that is helping us install all of these LSPs, dApps, linters, anything. So if we go through it, we pretty much see that it supports many languages right away. Um, your regular Angular, Ansible, if you have worked on it, if you're working on Arduino based C, AWK, Bash. So as soon as LSP came out, everyone started gunning towards writing these LSPs for their languages. So you will see most of the languages having their LSP right here. You'll see TypeScript, you'll see everything that you might have worked on in general. You'll have Go. Even we have language for Grammarly. So the regular thing that you use on web, if you want to write some text and stuff, you can find this language server here, and then you can actually write text here, and then it's going to suggest you stuff. Your regular Java, Lua, all of the languages and stuff you can find in all of these here. Similarly, we have dApp, the debug adapter for different languages that we see per se. It's not available for all the regular languages per se. All the C, CPP, those kind of things fall in one thing. Your regular Node or Chrome, your Chrome debugging or Firefox debugging will fall into this. In general, you have a Go debugging stuff and stuff like that. You'll have a lot of linters depending on your language and stuff. We'll not go into linters. It's like linters or formatters, but yeah, we know what they do on a high level. Yeah, cool. That's on the list. We'll go through some Git support to see, like these days, most of the time we are working with some Git projects, and how does this fare on a Git base, right? So we can actually see all the Git files that we have, anything that is added to Git. This ignores all your things that are present in Git ignore and stuff like that, and shows you things here. More akin to your, like if you have some ID like IntelliJ, your double shift might show you all the files, or if you're using VS Code, your Control P might show all the files in the project and stuff like that. So we can go through some files. Let's say these are all of the files that are present, and let's say we want to like many a time people might want to go through blame, so we can actually go through it, see which commit added it, and what did we do per se. And let's say if we start adding some stuff, adding some extra stuff, right? It immediately shows us this. I'm guessing it's green color. Like whenever we are adding some more stuff, it shows that. And if we are editing some thing, it shows yellow. That we are editing some existing stuff. If we remove something, it shows that red line. Let me do it at a place where it's not maybe in a different file. I'll show you the red stuff like when we add in general. With this, what we can do is we can actually jump from one change to the other place. Like we can go to the next change per se in the same file. Like let's say I'm here. Let me add some extra text above, and I've added something below, right? I can actually switch from my current change to next change. Usually, most of the time when we are working on a project, we will be working in hunks. We will be adding some code here, some code there. We can jump from one hunk to the other hunk in general. I'll let's say I deleted this, so that's how our red line will look like. If we want to see what we have added or removed, it will show in this preview window of what we did. Right, we can actually see, okay, we this minus indicates that we have removed some hunk from there. So the more we get going with this stuff, the more we'll get used to it. We'll also get your regular Git staging, all of those stuff. This is the Git status view. We can go to the changes where we did, and we can stage our changes, or we can revert those changes. Like if you want to add this change, you can stage it. And if we want to remove that change, we can also ignore it. Like v.md, if I am ignoring the changes that I did, I can ignore that. Then we only have changes in v.md. We can do a commit, your regular commit message thing that we do. We can do that from here. If you see v.md is completely unchanged as we removed all of that. Yeah. So that's on Git per se, Git integration as part of our demo. Our regular finding files or find files we have already seen. We can see a.md, like if you search for it, we will see those things. If you want to find the content in file, then we can search for it, and then it's going to see which file and what line it is. And we can also see the preview of it on the right hand side. So basically, all of those things will be available as part of this setup. Proceeding further, any questions? Okay. I don't see any questions. I'm proceeding further. One more thing that is going to on terminal give us a lot more visual hints is more of these symbols that we see, like showing that we are on branch master. If we switch to a different branch of Git, it's going to show us here. It's going to show us what file type it is. And if we go to this file here, we can see the tick marks saying that we have added the stage in the changes, stuff like that. Also the yum down shows markdown, all of those things are supported by this nerd font that are coming. Yeah. These are like very small things of each, but they all combine together to give us this experience of what we are going through right now. Right? These are all like individual. Most of it are all open source software that we are using to have this kind of experience, um, have this wonderful experience to go through as we have studied, right? So basically, to do this setup on our own, the basic resources that I have put up are anyway our hardware resources and hardware links. I'm going to put up in this deck and then have it in place. Whatever I have created the setup in general on the Termux, the setup, most of it is present as part of a backup file. Meaning as part of this backup, we will see all the things that are needed for this installation. Like we needed NeoVim, we needed Tmux, all of this. We need not install one by one. Restoring this backup on Termux will help us have all of those pre-set up in general. And all of the NeoVim config or Tmux config is present in this GitLab repository, which I think people can take it more like a initial config, and then they can edit all of the settings to their IDE as they feel like in general. Yeah. We are almost end to the top. Mostly these are the hardware resources that I have like I've tried out this cast thing, AnyCast from Amazon. I've bought it and then tried it out. And then this is linked to Raspberry Pi if someone wants to buy it. Software links more on NeoVim, Termux, all of the links of those things are present here. Any questions?
I think seems like there are no questions, Sultan.
Sure.
Yeah.
Good.
So like folks, like we are at the end of the event. So in the chat, I have put in feedback form. So please add your inputs so that we can improve the event better next time. And yeah,
Good.
thank you Sultan, for your time. And
Sure. I was also going to add that the same demo, I've done it for 3 or 4 college students. They are more on the willing side to try it out and see how things will flow. We'll see how this thing will flow.
Okay, sure, Sultan. Like, we will be sharing the recorded session in the mails. So yeah, we can include
Sure.
those as well.
Yeah.
Yeah.
Cool. That's pretty much it. Thanks, everyone.
Thank you, everyone. Thank you for your time and patience.